I am beyond thrilled to introduce to you this morning Dr. Hailey for our welcome keynote. She's the Dean of the College of Science and Engineering at Texas State University. Chris, please.
Good morning. As I look out at this group, I feel like a number of you could also give this talk. And so if I say something wrong, don't raise your hand and correct me, just sort of go with it. But for those of you who haven't heard about the College of Science and Engineering, I'm just going to frame who we are, what we do, and leave you with the important idea that we are part of the San Marcos Partnership, and we have capabilities that we're proud of, but that you might find interesting as well. So, it is a College of Science and Engineering. Engineering is relatively new to Texas State, but often will overshadow science, but we have chemistry and physics and computer science and mathematics and engineering technology, the sorts of other programs that round out a college. Am I good? Oh, are you keeping up with me? Okay. I think it's important to begin with a mission, so you have a context for Texas State and for the college. And you should realize that we're kind of one-stop shopping in that we prepare students for all of STEM. So we have science, we have technology, we have engineering, we have mathematics. And we also prepare teachers, and I cannot tell you how important it is to have a really good K-12 STEM teacher at this part. And we also teach the gen ed courses. We impart core knowledge in science and engineering to all students. Every student on campus has to take 1 math and 2 sciences, and we help with that. We also are very proud of our research, but more importantly, the environment that we're trying to create so that we can sustain research and do internationally important work. And then finally, because we are a public institution funded by the state of Texas, we think it's really important that you know that we serve the citizens of Texas and that we are really interested in innovation and economic development. Okay, now I'm going to click. Excellent. This is who we are. We have biology, chemistry, biochemistry, computer science, a large school of engineering, engineering technology, mathematics, physics, and 2 centers. We do work with water research with the Edwards Aquifer Research Center, and we're also very proud of our material science, engineering, and commercialization doctoral program. So this is what we look like. These are numbers. It's Texas. I've been in Texas since 2016. And one of the things I've learned about Texas is that things are always bigger and brighter and better in Texas. So I will just tell you, I've figured that out. And in Texas State, we are the biggest, brightest college. We have the most students. We have about 6,100 undergraduate students, 470 master's students, 140 PhD students. We're very proud of our demographics. We look like Texas. We are a minority-serving institution. 42% of our undergraduates are Hispanic, 11% are Black. We're predominantly a male college, and we continue to work on that, 62% male. There's a shift in what our graduate program looks like, but notice we also have 15% students, Hispanic students in our graduate program, and we level the playing field a little bit more between male and female. Our research expenditures, if you are coming from a large R1, I would have to say they're modest, but they're $8 million a year, and they're growing, and we're particularly proud this year. We have 3 faculty who have career awards. If you're not familiar with the National Science Foundation Career Award, that is like the most prestigious award you can get as a young investigator. It launches your career because your work is so impactful. And we have about 330 faculty and 78 staff. So that's the college by numbers. Okay. I'm going to only talk now about the Ingram School of Engineering because I think that tees up the work that Jason's going to talk about and then the panel a little bit later. I borrowed this. Jesus is in the front row. He's the director of the Ingram School of Engineering, and this is one of his slides. We have electrical engineering, manufacturing engineering, industrial engineering. Those are ABET accredited. They've been around for about 10 years. Civil engineering is in its 3rd year. We have about 300 students, freshman, sophomore, junior. A year from now, we should graduate our first class. We'll apply for ABET. And we've got mechanical engineering queued up. Mechanical engineering is very, very important to us. And in October, a number of us go to the Texas Higher Education Coordinating Board to defend our proposal for mechanical. If we're successful, fall 2022, that's a year from now, we should be admitting freshmen to mechanical. So the Ingram School of Engineering has grown since I've been dean. I suspect they hired me, I'm a mechanical engineer, to help grow this part of the institution. I want to spend just a minute talking about civil engineering because I think we're really proud of the fact that we may be among a handful of undergraduate programs that are focused on technology-enhanced infrastructure. And since this is Digital 360, all things digital, what we pride ourselves in is, of course, the students will be excellent civil engineers. They will be grounded in transportation and environmental engineering and structures and water, all those sorts of things you would expect. But we also realize that our students need to be prepared for a technology-enhanced infrastructure. Roads are going to be smarter, and bridges are going to be smarter. And bridges are going to talk to transportation centers, and we will have adjustments as we go in terms of data management and analytics to adjust everything from traffic flow to shut down that lane because we think the whole asset is about to break down. Ditto for water, whether it's clean water or it's processing wastewater. So we pride ourselves on what we call technology-enhanced infrastructure, and we weave that theme throughout so that the students not only are good civil engineers, but they also can understand data management, analytics, and asset management. 2 days ago, we did the groundbreaking for our infrastructure research lab, and I highlight that, so when you look at it, it is kind of a shell with a strong floor and a strong wall, just what you would expect for civil engineering so that we could test large structures. We could put bridge sections in there. We're not putting dumb bridge sections in there. We're really interested in ways to innovate assets so that they are smart. In fact, we often use the word connected. The infrastructure is connected to a bigger space, and so maybe we should have renamed this the Connected Infrastructure Research Lab. And that may be something we'll think about in the future, okay? And needless to say, this is where our students and our faculty are going to actualize technology-enhanced infrastructure. And, you know, a natural, of course, is concrete. But we also have folks who are interested in permeable pavement, rain gardens, bioretention, wetlands. As we move into this critical area of sustainability, there's a lot we can do in this building. The beauty of it, it is all concrete, and you can do all kinds of stuff in a large space like that. In fact, I would argue that Andreas and others, while we were scratching our head over what are we going to do with this big building that's just a bunch of concrete, I would say that in the discussion of what to do with that building, we gave birth, and you were instrumental in this, in the notion of CEDAR. And you guys have heard of CEDAR before, but this idea that infrastructure is going to be connected. It's connected to the digital world, and we need places where we can demonstrate, where we can do applied research, and where our students can get smarter about this connected infrastructure. Okay, 2 more, and then I'll turn this over to you, Jason. This is what mechanical engineering looks like. We're calling it ME 4.0, but once again, the idea is we need to make good mechanical engineers. So they're going to be good at energy, they're going to be good at fluid mechanics, they're going to be good at structural analysis, everything you would expect of a good mechanical engineer. But we're going to overlay on that a lot of the concepts of Industry 4.0 because that makes sense for where we are in the corridor. And so the students will have a number of classes focused on digital twin and simulation and robotics and cybersecurity and 3D printing and Internet of Things and big data. basically preparing somebody who is conversant with Industry 4.0 in addition to classic mechanical engineering. And of course, it goes without saying, all our programs must be ABET accredited. Okay? So, at this point, it's kind of a quick look at science and engineering. Here are my takeaways for you. We're proud of the College of Science and Engineering, and we view ourselves as an asset to those of you who are interested in connecting because you've got industry ideas and you need help with development. You may need help with some, fundamental research. Within science and engineering, we have a strong school of engineering getting stronger every day. And with mechanical around the corner, we'll have the classic electrical, civil, and mechanical. CEDAR sits at a higher level at the university, but we are definitely part of the CEDAR initiative. And basically, we have one goal. Well, we have many goals, right? We have about 6,100 undergraduate goals, which is to help them all graduate and contribute to Texas with the workforce. So we really are very much about students, but we also think that in terms of our capabilities, we can make a brighter future for Central Texas. And so with that, I'll thank you, and I'll turn the time over to Jason.